These last two problems are going to be u-substitution problems where we have to do a little bit of work to make sure that everything actually is substituted. So for this example, here you can see I've got an integral of x over the square root of 1 plus 2x. Now, as usual, we're going to see maybe the smartest thing to try is to let u be um, the stuff that's under the radical or that's in the power. So that's fine. But when we take the du dx is just going to be 2. So du is 2 dx. And that's also fine. But the issue is we have this little x up here, right? So if I start to make my substitutions, I can see immediately I have a u here. Okay, so maybe I should write dx, d1/2 du is dx. So then I have a 1/2 du here, but I have an extra x. So that in our previous examples, maybe what was on the top there went with the dx or somehow it was substituted, but here I haven't substituted it yet. So what I need to do is I actually need to go back to my chosen substitution, this u equals 1 plus 2x, and solve that for x. So if I go back to there and solve for x, I can then actually substitute for x. So this would be u minus 1 equals 2x, or x equals 1/2 u minus 1. Okay, so that goes up here. All right, that looks ugly. Let me rewrite this. That 1/2 goes out. I'm going to put all the 1/2s out. That makes 1/4. And I have u minus 1 over square root of u du. Oh, I left off my limits. Better not leave off my limits. Okay, let's put those in. When x equals 0, u equals 1. When x equals 4, looks like 1 plus 8 would be 9. So this becomes 1 to 9, becomes 1 to 9. And now this one, I'll try to see if I can put it. You know what? Let's do this. Let's bring him down here. Let's bring him down here. So this is going to be equal to 1/4, 1 to 9. U over the square root of u would be square root of u, and then minus 1 over the square root of u, right? Maybe it would have made more sense for me to write it with 1/2, u to the 1/2 minus u to the negative 1/2. Integrate that guy. Easy peasy, right? Now I'm good. Minus u to the 1/2 and a 2. Evaluate from 1 to 9. We kind of squeezed that on there. That wasn't very nice. Let me try to make that more legible. 1 to 9. Okay, and so now we're just going to evaluate that and figure out what our number is. So I have 2/3 times 9 to the 3/2 minus 2 times 9 to the 1/2 minus, I'm just going to pull the 1/4 out of everything. 2/3 times 1 to the 3/2 minus 2 times 1 to the 1/2. Right, so that's just 1. So this would be, okay, so 9, so that's 3. 2/3 times 27 minus 2 times 3 minus 2/3 plus 2 looks like, right? Right. See if I can get this here. So this would be 2 times 9, so 18 minus 6 plus 2 minus 2/3. So 14 minus 2/3, always with this stuff. Oh my God, let's see what finally, I have 14 times 3, 42. So this is 40 thirds. So this would be 10 thirds. And that's my answer. Okay. So just to recap real quick, what we had to do, we did pick the right substitution. It worked pretty well when we got it all together, but we had that extra piece in there that we needed to solve for. So sometimes that will happen. Let me do one more where you have to do that. Here, it was pretty clear that there was a problem. If you remember, once we started putting the stuff in, that extra x was sitting there. This one, it might not be that clear. This is problem 79 in the book, but it's something somewhat similar. Because here again, if I look, I've got a power of something to the -4, so I want to let that thing be my u as a first trial, right? Then I get du, it's going to be du dx, let's just write it that way, 1/2 x to the -1/2. So I end up with du is 1/2 root x dx. Okay, now if I have 2 dx's, sorry about that. So now if I write this out, I have again sort of the similar problem, right? In our other problems, we just had like an x, a 2 or a 4 or something. We can always pull out a constant, but I can't pull out a square root of x, right? So if I try to do this substitution, I've still got a mess here. Not u to the 4 in the bottom, but I've got a similar problem that I had in the previous one, where now I've got something I need to substitute for. So I have to substitute for that square root of x, but again, given the substitution that I found, I can substitute for it pretty easily, right? So I can use this to write square root of x equals u minus 1. So then what I'll end up with is 2 times u minus 1 in the top divided by u to the 4th. Okay. All right, so that looks pretty good so far. I better check those limits and get that right. So when x equals 0, u equals 1, 1 minus 0. When x equals 1, u equals 1 plus 1, which is 2. So that's nice. All right, so we can clean this one up a little bit better as well. I'm going to take that 2 out in front, and then I have u over u to the 4th minus 1 over u to the 4th, so I don't mess it up. All right, let me move myself down here to the bottom again so we're not like shoved up in the corner. We're going to put this. Let me rewrite this so we can see it a little better. It was the integral from 1 to 2, u to the -3 minus u to the -4 du. So just rewriting that way, now I can go ahead and do my antiderivative. Now remember, it's u to the n plus 1 over n plus 1, but of course I've got a negative, so this is going to be this, right? And if you forget whether you're going plus or whatever, always just take the derivative and make sure you got the right thing, right? So if I take the derivative of u to the -3, I'm going to get -3 u to the -4. That's exactly what I want. So it's just a good mental check to double check that you're okay. All right. So let me write this though, because plus 1 over 3u cubed. If I'm going to figure out the numbers, I want it in a form that I like to look at a little bit better. So clean that up to there. Let's see what we got. Evaluate at 2. I got 1 over 2 times 4 is 8. plus 1 over 3 times 8 is 27. Subtract at 1, I'm going to get 1 over 2 plus 1 over 3. I'll see if I can add my fractions right. Right, so first of all, you know what, I will screw up if I do too many steps in my head. So I'm going to distribute that negative specifically because I know that if I don't write it separately, I will screw it up. So now common denominator clearly is going to be 24. That's easy enough, right? So this would be minus 3 plus 1 plus 12 minus 8. So what is that? Um, what did I do? 4 minus 3 plus 1 is 2, so that gives me 1/6. That is the right answer. Woo! Okay.